Likes composite functions, but you need to do them a lot in calculus. So we have two functions, f of x equals x plus 1, and then g of x equals x minus 1. So for part A, and just to kind of remind you guys, if for your I don't think it's time to go. Is it? All right. So f of 0 means that wherever there is an x, I will plug in 0. So f of x, which is equal to x plus 1, if I say f of 0, that would give me 0 plus 1. You guys remember that for the function notation? Yeah. So now for part A, they say give me f of g of x. So we do the same thing. F of x is x plus 1, but when they say f of g of x, instead of an x, I'm going to plug in a g of x. Does that make sense? So now g of x is actually x minus 1. So on the next line, I'm going to plug in x minus 1 where the x was. Does that make sense?
Yeah.
All right. So now if I clean that up a little bit, the ones cancel and I get f of g of x is equal to x. Does that make sense?
Yeah.
All right, so let's move on to the next one. So now the next one says, hey, what about g of f of x? Well, same thing. G of x is x minus 1, right? So we look up here, this is x minus 1. So instead of putting x minus 1, I'm going to put f of x minus 1. Well, what is f of x? Well, f of x was x plus 1. So I'm going to write g of f of x is equal to x plus 1 and then tack on the minus 1. When I clean that up a bit, I get g of f of x is x. Does anybody remember what that tells us when we do the composite of one and the other and we get x both times? They're inverse functions of one another. You guys should know this. You should live it. You should breathe it.
Teach it.
Yeah, I don't know who taught you guys pre-calculus last year. All right, so now for C, we're actually asked to find g of 0. So remember that f of x is equal to x plus 1. So when we say f of g of 0, then we're really looking for g of 0 plus 1. Well, that means that we're going to come in here, and wherever there's an x, we would plug in a 0. So 0 minus 1 is what we're going to plug in way down here, right? So f of g of 0 is the same as saying 0 minus 1 plus 1. And so when we clean that up a bit, our final answer is 0. Shall we continue? Alright, so now, g of x is x minus 1. So on our very next step, they ask us to do g of f of 0. So again, we plug in f of 0, but remember f of x is x plus 1, but f of 0 will be 0 plus 1. So 0 plus 1 minus 1 equals 0. Now I'm going kind of fast, but does that make sense to you guys?
Yes.
Okay, good. We are almost done with that one particular problem. You have to make those noises sometimes. So remembering that g of x is x minus 1, if I were to evaluate g of negative 2, it would be the same as negative 2 minus 1, which is negative 3. So when they ask us to evaluate g of x, which equals minus 1, I'm going to evaluate g of negative 2. This is really the question they're asking us. I'm just ramping up to it. G of negative 2. So I plug that in, which is really negative 2 minus 1 minus 1, which when you add all that up is negative 4. Holy moly. Alright, so then the next question they ask us is what is f of x, f of x? So remember that f of x is x plus 1, so when we say f of x, we're, instead of putting the x plus 1, we're going to put f of x plus 1. And then we've got, well, what was f of x? Well, f of x is x plus 1. So we really have x plus 1 plus 1. Clean it up a little bit, you get x plus 2 is your answer. Wabam with the bacon sizzle. Any questions?